So for today's lesson, we're going to be covering Chapter 7, Section 4, Division Properties of Exponents. If you're following along, we're on page 439 in the textbook. So the first thing we're going to do is a little homework review. In the first problem, we have m to the 4th all raised to the 10th power. Now I saw some of you guys adding 4 plus 10 to get m to the 14th power. That's wrong because we're not multiplying. You would, to get it to the, for m to be to the 14th power, you would have to multiply m to the 4th times m to the 10th, but we're raising m to the 4th power to the 10th power. So what we have to do when we do this, when we have an exponent to an exponent, we're going to end up multiplying. So we're going to have m to the 4 times 10. 4 times 10 gives us 40, so our answer is m to the 40th. In number 2, we have h squared times h to the 7th to the 0 power. Now before we can do h squared times h to the 7th, we have to do h to the 7th to the 0 power because of PEMDAS. Remember, exponents comes first. So what we do is we have h squared times h to the 7th times 0. 7 times 0 gives us 0, so we're left with h squared, h to the 0. Now because we're multiplying numbers or multiplying variables with the same base, you go ahead and add those two exponents. So we have h to the 2nd plus 0, or h to the 2 plus 0. 2 plus 0 gives us 2, so your final answer is h squared. In number 5, we have in parentheses 9 d to the 10th, close parenthesis, to the negative 2 power. What we have to do with this negative 2 is we have to distribute it back to each number and each variable that's in that particular set of parentheses. So we're going to bring it to the d to the 10th power, and we're also going to bring it to the 9. So we're going to be left with 9 to the negative 2, d to the 10 times negative 2 power. I went ahead next, and we're left with 9 to the negative 2, d to the negative 20. 10 times negative 2 gives us negative 20. Remember, we don't like negative exponents. We have to make them positive, and the only way to do that is to bring them down into the denominator. And when we do that, they become positive. So we're left with 1 over 9 squared d to the 20. And we can go ahead and simplify 9 squared, and our final answer is 1 over 81 d to the 20th power. In number 8, we have z, and then in parentheses, y to the negative 5, z to the 7, close parenthesis, all to the negative 1 power, and then we have y to the negative 5. What we got to do with this negative 1 is distribute it back to each variable that's in that parenthesis. So it's going to be to the y to the negative 5 power, and then to the z to the 7 power. Now I go ahead, we're left with z, and then parentheses, y to the negative 5 times negative 1 power times z to the 7 times negative 1 power, close our parenthesis, times y to the negative 5. I go ahead and multiply, so we're left with z times y to the 5th, z to the negative 7, y to the negative 5. Now what we could do is group our like bases together. So we're going to group our z's with our z's and our y's with our y's. So we're left with z to the negative 7 plus 1 and y to the 5 plus negative 5. We're adding the exponents now because we are multiplying all these variables together. Up top, we multiplied them because it was a power to a power. Down here, we're adding because now we're multiplying z times z and y times y. Negative 7 plus 1 gives us negative 6, and 5 plus negative 5 gives us 0. So we're left with z to the negative 6, y to the 0. Remember, we don't like this negative 6 here. We got to make it positive. The only way to do that is put it in the denominator. So our final answer is 1 over z to the 6. What happened over here with this y? Well, because it was to the 0 power, it just becomes 1, and you don't need to go ahead and write that in. As promised, your pet of the day. So this is a proud PC alumni's dog. Her name is Bella. Bella's owner works in the hospital, so let's give Bella's mom a nice thank you for all her hard work that she's been doing. Now we're going to focus on Chapter 7, Section 4, Division Properties of Exponents. So when we're dividing numbers with the same base, we're going to end up subtracting the exponents. So if we have a to the m over a to the n, and where m and n are our exponents, we're going to do a to the m minus n power. An example with numbers and variables would be as follows. X to the 7th over x to the 4th. Same base, they're both base x, so we're going to do x to the 7 minus 4. We go ahead and subtract 7 minus 4, and we get x to the 3rd. So x to the 3rd is our final answer. To raise a quotient to a power, so you're going to have a fraction, raise the numerator and the denominator to the power and simplify. So what that means is you're going to have in parentheses a over b all to the n power. So we're going to have a to the n over b to the n. Let's do that with numbers. So in parentheses, we have 3/5 all to the 3rd power. So now we take this 3, distribute it to the numerator, distribute it to the denominator. So we're left with 3 to the 3rd over 5 to the 3rd. 3 to the 3rd gives us 27. 5 to the 3rd gives us 125. Your final answer is 27 over 125. Let's practice this one. What is the simplified form of x to the 7th over x squared? Same base, they're both base x. Now we can subtract the exponents. So we're going to do 7 minus 2. 7 minus 2 gives us 5, so our final answer is x to the 5th power. What is the simplified form of the following expression? Y to the 10 times y to the 0, all divided by y to the 7. First thing you should do is because we're multiplying, y10 times y0, add the 10 plus 0, so we're left with y10 plus 0, all over y to the 7th. 10 plus 0 gives us 10, so we're left with y10 over y7. So we do y to the 10 minus 7. 10 minus 7 gives us 3, so your final answer is y to the 3rd. What is the simplified form? Here we have x to the 3 halves power divided by x squared. What we do here is, it's okay that we have a fraction, we could still subtract a fraction from a whole number. So what we go ahead and do is x to the 3 halves minus 2 power. We can't do 3 over 2 minus 2. It wouldn't be 1/2. What you have to do is find your common denominator to subtract a whole number. So we have x to the 3 halves minus 4 halves, and our final answer is x to the negative 1/2 power. Remember, this is still a negative number or a negative exponent, so what we have to do is make it positive. And the way we do that is still put it down into the denominator, and we're left with 1 over x to the 1/2 power. What's the simplified form of this? In parentheses, x over y, all to the fifth power. So we go ahead and distribute the fifth power to the numerator and the fifth power to the denominator. So we're left with x to the fifth over y to the fifth. Final answer, can't do anything else with it because we can't subtract the 5 minus 5 because one's an x and one's a y. Let's try this one. What is the simplified form? In parentheses, we have 4 over x to the third and all of this raised to the second power. So what we have to do is distribute the 2 to the numerator and the 2 to the denominator. So we're left with 4 squared over, and now we're going to multiply 3 times 2 because it's a power to a power. So we're left with x to the 3 times 2. We could go ahead and simplify. 4 squared gives us 16. 3 times 2 gives us 6. So your final answer is 16 over x to the 6th power. So your homework for tonight is on Plus Portals. Make sure we're emailing it and submitting it to me on time. On Friday, you guys will have a quiz on 7.1 to 7.4. Make sure we're emailing me if you have any questions.